Hello everyone, welcome to another video. I'm here again with another important topic of organic chemistry, which is IR spectrum. Here I have a sample of IR spectrum. So let's look at the axes first. In the bottom, the wave number is telling us about a particular energy of the infrared light. So infrared light is a certain band or certain part of the electromagnetic spectrum that ranges between 4,000 to 600. And there are many energies of infrared light in between. So we're exposing our sample with all of these infrared light of all of these different wavelengths. And the wave number are here, the way that we can differentiate between all those individual energies of IR radiation. On the y-axis, we have the transmittance or the percentage of the particular wavelength or the particular wave number that reaches the detector. So if we have information, for example, close to 100 or at 100 transmittance, that means that the IR light corresponds to that wavelength is all getting through the sample and it's not being absorbed by anything in the sample. And if we have some peaks or some information, this means that there is something in the sample that can absorb the IR light. So this indicates the presence of some particular functional groups in the compound, some functional groups in the sample that can absorb the IR wavelengths. So this information is here to tell us about what kind of bonds are present in the compound. So I have divided this image in a few sections. For example, the first one we have right above 2500. So all the peaks that we have above 2500 until 4000, they're all the peaks between the atoms that have a single bond with hydrogen. For example, oxygen, hydrogen, nitrogen, hydrogen, or carbon, hydrogen. So they're all the single bonds with the hydrogen. The other section is right over here above 2000. So from 2000 to 2500, we have all the atoms that have a triple bond with the other atom. So for example, carbon-carbon, carbon-nitrogen, or carbon-oxygen could be in this range. And in this range, there might be some bonds, but they can either be triple bond or double bond. It's not really clear for us. For 1600 to 1800, there are all the peaks. All the peaks correspond to the double bond atoms. For example, carbon, oxygen, carbon, nitrogen, or carbon, carbon double bonds. And from 1500 below, this region is called fingerprint region, which is kind of complicated to analyze. So we're just going to leave it for this video, and it's going to go beyond the scope of this lesson as well. And there are some peaks over here as well. So these peaks are medium, weak, or strong peaks. So these peaks depend on the relative intensity in the infrared spectrum. So when the peak is the strongest, it means that it has the lower transmittance percentage. So some characteristic of IR range, so of some organic compound over here, I have listed a few. So we have the oxygen hydrogen sigma bond. So the peak for this group is broad and it's round and broad. So it always ranges between 3200 to 3600 per centimeter. And for the alkyne, which is a carbon hydrogen sigma bond, and also the carbon can have a triple bond with the other carbon or with the other group. So this ranges between 3250 to 3350 per centimeter. And I have the information for the alkene and for the alkyne as well. So all of the atoms that have a sigma bond or a single bond with the with hydrogen, they're all above the 300. Only the alkene group, which has a single bond with the hydrogen, so the carbon also has a single bond with another atom, so this can be lower than 3000, which is like 2850 to 2950 per centimeter. And for the nitrogen hydrogen, the range is between 3300 to 3500 per centimeter. Also because it has a sigma bond with the hydrogen, so it's always above 300. And for the double bonds, so they can have sharp or they're always the peaks are always sharp for the double bonds. They can sometimes be weak or sometimes can be strong, and they range between 1500 to 1750 per centimeter. And the triple bonds, for example, we have carbon-carbon triple bond, carbon-nitrogen triple bond, or carbon-oxygen triple bond. These all bonds will be between 2050 to 2250 per centimeter in the IR spectrum sample. So here are some important functional groups, for example, aldehyde, ketones, ester, carboxylic acid, amide, and anhydride. So I have listed all the ranges of the peaks that they can be in the sample. So it's easier for you guys to refer to it anytime. For the anhydride, I just want to point out something over here for the anhydrides. So the anhydrides can have two peaks in a sample. They can either be between 1830 to 1800 or 1775 to 1740, and they can be strong or weak. So for example, this image that we have over here, I have all the information above. We have the so as we see in the molecular formula, we have a oxygen hydrogen sigma bond. So this the peak will be broad and round for this group. So the first thing that we can see in the sample, the graph, that the first peak is round and it's broad. So we can determine this as a oxygen hydrogen group. And also we have a carbon hydrogen sigma bond also. It's a little bit below 3000, so it's between 2850 to 2950 per centimeter. So we can say that this peak is strong, and also this peak is for hydrogen and carbon sigma bond. And also, as we see in the molecular formula, there is a bond between oxygen and carbon, which is a single bond. So this can be between 1100 to 1250 per centimeter, which can be shown here in the graph. Another example is propylamine. So I have the molecular formula as well. Always the molecular formula is so easy for you to, if you have it, it's going to be very easy for you to determine all the peaks because you know what kind of bonds are present in the molecule. So I have the information over here as well. Let's look at the the nitrogen hydrogen first. So we said that the hydrogen, whichever atom has a sigma bond with the hydrogen, they always be above 3000. So we have 3300 to 3500 per centimeter. As we see in the graph, there are some few peaks that are above 3000. There are two kind of medium peaks. They're not weak, they're not very strong, but they're kind of medium. So this can be the nitrogen hydrogen sigma bond over here. And also, as we see in the molecular formula, there's a long, it's not a long carbon chain, it's a medium carbon chain also. And we can see that there are some peaks just close to 3000, not like it's not above 3000, but it's very close to it. So this can be a peak for the hydrogen and carbon sigma bond over here. Another example over here, as we see in the molecular formula, we also have the triple bond between carbon and nitrogen. So we're going to find the triple bond as well. Here I have all the info. So the triple bond for carbon, carbon, nitrogen, carbon, oxygen, they're all in the same range. They're between 2050 to 2250 per centimeter. So we can it's easier for us to determine which peak is which peak is which functional group when we have a triple bond. And for the alkane, we have the bond between 2850 to 2950 per centimeter. So let's look at the graph first. We can see that there are a lot of weak peaks above 3000. So we're not going to look at that because this is not related to what information we have for the molecular formula. We have a few peaks right close to 3000, or also maybe it can be above 3000. So this can be for the hydrogen carbon sigma bond. And for the triple bond that we have for carbon nitrogen, this can be the peak for carbon nitrogen because it's between 2050 to 2250 per centimeter.